Hello, everybody. So in this example, I'm going to show you how to construct a chi-square test for homogeneity. So I figured it would be best to show you an example and then discuss the different steps throughout rather than giving you a PowerPoint display and going through each step like that. Now there is the PowerPoint display in the Google Classroom should you wish to refer to that too. So this is a chi-square test for homogeneity. So I'm going to tell you how to recognize when to use homogeneity and when to recognize independence. So here's our example. We have a large company planning to install drink vending machines in its office building. And they select simple random samples of both the professional staff and the administrative support staff. And they ask people to choose between two brands of drink machines. So they're either going to choose Coca-Cola or Pepsi. So here are the results right here. So we've got the drink brand, Coca-Cola and Pepsi, and then we got either professional staff or support staff. So as you can see, from the professional staff, 14 out of the 44 went with the Coca-Cola. So then the question is this: do these data provide evidence that there is a difference in the brand preferences of the professional and the administrative support staffs? All right, so we want to see if these two distributions are different. And then we're going to have to use a chi-squared test to support your conclusion. So then the question is, do we use a chi-squared test for goodness of fit? Do we use a chi-squared test for homogeneity? Or do we use a chi-squared test for independence? So the trick for doing it is this. If it's a chi-squared test for goodness of fit, you're always going to be asking, does one distribution match a given distribution? That's not the case here. So then the second question you want to ask yourself is, how was the data obtained? If it was obtained from two independent sources or two independent populations, then we're going to use a chi-squared test for homogeneity. And that's what we have in this case right here. So the first thing I always do before I start is I state what kind of test we're going to do. So because we're taking two independent random samples, we're going to perform a chi-squared test for homogeneity. And because there is no significance level assigned, we're going to state that we're going to use 5%. All right, so how do we start? The first thing you always want to do is compare your observed values to what you would expect to get. So I'm going to show you how to do that. So from this table up here, our observed values were 14, 30, 8, and 43. And then we have the totals here. So to figure out the expected values, here's what you would do. You take the row total and you multiply it by the column total, and then you divide it by the overall total. So here's what I would mean. If I was going to figure out the expected number for the professionals who chose cola, well, the probability of picking someone who chose cola would be 44 out of 95. So it doesn't matter whether they're professionals or support staff. 44 of those staff members are going to choose Coca-Cola out of the 95. So it's like you're doing 44. I'll show you on the calculator here. It's kind of like you're doing 44 divided by 95. That would be the proportion of people that would just pick Coca-Cola regardless. And then you're going to multiply it by all the professionals who would choose that. So because there's 22 professionals, we multiply it by 22, and that gives us our expected value of 10.19 if we round it. So that's where I'm getting that from. So remember, and a simple way to do this is you're always doing the row total, multiply by the column total, divided by the overall total. So let's say I was to do the support staff here. I would then do 44 multiplied by 73 divided by 95. So again, 44 multiplied by the total for the column, which is 73, and then divided by the overall total, which is 95. So I would expect 33.81 of the support staff to pick Coca-Cola. If this doesn't make sense, please reach out to me. All right, so once I've figured out all the expected values, remember, I'm trying to see if there's a difference between the observed counts and the expected counts every single time. But in order to do this test, I got to make sure that my conditions are right. So number one, random. and that's for each group. So yes, we took a random sample, or a simple random sample was collected from each group. Was there a 10% independence check performed? All right, so basically, because I'm not replacing, I need to assume that the number of professional staff is greater than 220, which is, remember, like the 22 is 10% of that. So is it larger? We can assume that if it's a large company, which it does say up here. And then for the support staff, we have to assume that that's going to be greater than 730. And then the large counts. Always make sure that your expected counts are greater than or equal to 5. And every single one of these values is greater than or equal to 5. So we're all good to go. Now, essentially, I should have started with the hypotheses at the very beginning, but I didn't. So let's refer to them right now. So with a test for homogeneity, you're trying to see if the distributions for the professional staff and the support staff are the same in their drink preference. So for the null, the distribution of drink brand preferences are the same for professionals and also for support staff. For the alternative, you just nullify it. So the distribution of drink brand preferences is not the same for professionals and support staff. Now, when we do our test calculations, we're going to need to come up with the degrees of freedom. When you're dealing with tests of homogeneity and independence, you do it in a subtly different way. So the degrees of freedom is always the number of columns minus 1 multiplied by the number of rows minus 1. So in this case, it's going to be 2 minus 1 because there are 2 columns, and then 2 minus 1 because there are 2 rows. So that would be 1 multiplied by 1, which gives us our degree of freedom of 1. All right, now we're all ready to calculate the test statistic. So remember, the chi-squared test statistic is always the same regardless of whether you're doing goodness of fit, homogeneity, or independence. It's always the observed minus the expected squared, all divided by the expected, and we sum up these values. So let's go ahead and do that. So the first group, the professionals who loved Coca-Cola. So that would be an observed value of 14 minus our expected value of 10.19, and then we divide it by the expected value again of 10.19. And we're going to do that for each of the 4 different variations. Now, when you're writing this out as a free response question, it's important that you start to show the work that you're doing as to how you would get that chi-squared value. You don't have to do it for all of them. You just need to show that you're starting off correctly. Now, let's just go over how we can figure out this chi-squared value. So let's go back to our calculator. So again, we're going to go to Stat, and then we're going to go to Edit, and we're going to put all of this in our tables of L1 and L2. So remember, L1 is going to be observed values, L2 is going to be our expected values. And we want to make sure that they match up. So here, the 14 observed professionals who liked Coca-Cola has to match up with the expected number of professionals who would like Coca-Cola. So make sure you're matching up each respective group correctly. Once you've done that, you can now figure out the different all the differences between the 2 groups. So we're going to open up some parentheses after highlighting L3. And remember, it's observed, so that's going to be second L1 minus the expected, so second L2, close parentheses, and then square, and then divide by the expected, which is second L2. Press enter, and these are our different contributions. So now what we want to do is we want to calculate the sum of this. Now, by the way, these contributions here basically state how much each individual group is contributing or impacting our chi-squared test statistic. If we look at these values, they're pretty low. There's not much difference between the expected values and the observed values. So it's leaning towards maybe that we're probably going to end up failing to reject the null. But we have to check the statistics before we can do that. So let's go ahead and sum up this row. So we'll get out of the screen. So to sum it up, we're going to go to list, so second list, go across to math, and then go down to number 5. And we stored everything in L3. So we could do that. And as you can see, we get a value of 3.453. So that's our chi-squared test statistic of 3.453. Now what we want to do is we want to come up with the p-value. So again, go back to our calculator. And for this, we can do second. And then we can go to vars for the distributions. And we're going to go down to number 8, which is the chi-squared CDF. And remember, we're always plugging in 3 values. If you're using the older version of the calculator, you'll put these in order one by one, separated by commas. So we've got our lower value of 3.453. Our upper value is always going to be a really large number. And remember, our degrees of freedom was 1. So we go ahead and paste, enter, and we get a p-value of 0.063. Excuse me. So our p-value, and again, this is showing how I figured it out. And there's the value that I got. So our critical region is this area to the right here of the test statistic. So same as before, you're always comparing the p-value to the level of significance. And remember, we chose 5%. So here's our conclusion. Because the p-value of 0.0631 is greater than our test statistic, than our significance level of 5%, we would therefore have to fail to reject the null. So what does that mean? Well, that means there is not sufficient evidence to suggest that the drink brand preference is different for each staff group. And that's what we were trying to find out. So really, whether it's Coca-Cola or Pepsi, whether you're staff, whether you're support staff or professionals, there really isn't a difference between those two distributions. Okay. In the next couple of videos, I will show you how to calculate a test for independence, and I will also show you a much faster way of calculating the chi-squared statistic and also the p-value in one fell swoop. And I believe you can do that on both calculators. All right, thanks very much for listening. If you have any questions, please reach out to me. Communication is always key here. Thank you very much.